Alright, here's a solution to another example. We're going to find the magnetic field at a point in space due to two sources. Two wires are separated by 10 centimeters. The wire on the left carries 15 amps, the wire on the right carries 11 amps. Each wire is 5 centimeters long. Find the B field exactly between them. So I'm finding the B field at a distance from a point in space. That means I'm going to use Ampere's law to do that and the closed right-hand rule to figure out the directions. And if the directions go in the, if I use Ampere's rule twice, because I have two currents here, if the B fields go in the same direction, I'm going to add them up to give me the same magnetic field. If they go in opposite directions, I'll declare one of those to be positive and the other to be negative, and I'll end up subtracting them. Alright, so first we'll start with the closed right-hand rule. We're going to look at the wire on the left, and I can see my thumb's coming out because that's the current. So the current's coming out of the page in this case, flow of positive charges, because the energy goes from high energy to low energy, which is positive charge flow. So it's going around in a counterclockwise direction. And that means if I look in between the two wires, the B field's going straight up. Now let's look at the other wire. The other wire has a current going into the page. So I'm going to take my right hand, put my thumb into the page. That's going to give me, this time, a clockwise rotation. But in between the two wires, it's also going straight up. So because I have both of these going up, they're going to add, because they're both going in the same direction. Again, if they were going opposite directions, I would declare one of them to be positive, and I would subtract them. But this time, they're both going the same direction, so I'm going to add my two B fields. Now all I do, since I know the directions, is I got to find out how big each B field is, and then add them together. So to figure out how big each B field is going to be, what I'm going to do is I'm going to use the closed right-hand rule and Ampere's law. So the B field on the left, and then the B field on the right, they're going to add up, combine tip to tail, give me one big B field at that location. Alright, so the total is going to be the sum of the left and the right B fields. Mu naught I divided by 2 pi r. I'll do it first with the 15 amp current, and then I'll set this up for the 11 amp current, and then I'll add the two together. It gives me the total magnetic field in between these two wires is going to be 1.04 times 10 to the negative 4 teslas, or 104 micro teslas.